All right. So, getting started with the order of operations. The order of operations is listed over to the left side here. I really like these notes because it uses the order of operations that I actually teach. I do not teach PEMDAS. I teach GEMDAS because there are many more ways to group numbers than just parentheses. So G for grouping symbols instead of P for parentheses. Yes, parentheses is one of them, but you also have brackets and braces and fraction bars, numerators, denominators, absolute value, square roots. Those are all ways that you can group numbers. So if you have groups of numbers within those types of symbols, always start there. Then you move on to exponents. It also says roots, but if there are multiple things to do under a root, that would be considered a group. So if there's only one thing under a root, basically treat that on the same level as an exponent. Otherwise, if there's multiple things under a root, do those things before. Multiplication and division, those hold the same level of importance. So if you have multiplication and division, you perform those from left.
Group of juniors, last names M through R. Please go to the library to check out a Chromebook.
Juniors, last name M through R. All right. Multiplication hold the same level of importance, and so if division happens in a problem before multiplication, as you're looking at it from left to right, do the division first. You do not have to multiply before you divide. Same with addition and subtraction. If subtraction happens before addition from left to right, do the subtraction first. So those are your quick reminders on that. I'm going to move very quickly through a lot of this. So let's see. Number one, I see one group in the parentheses here, and then within groups, you also have to follow the order of operations. So for example, within our group here, we have exponents, so we'd start with that exponent. So it'd be 2 to the power of 3, which would not be 2 times 3, it'd be 2 times itself 3 times, which equals what? What is 2 times 2 times 2? 8, yeah, 2 cubed, 2 to the third power is 8. Now, you are welcome to perform multiple operations at the same time if you want to. In fact, those scientific calculators, if you know how to use them, you can actually just type in that whole thing and it'll give you an answer, to be honest, but I like to review the process as well. So generally what I do is I'll try to do multiple things in the same step, just so I don't have to like write out the problem like 12 times to get to the correct answer. So I'm just going to do everything inside the parentheses. So I'm going to rewrite 29 and then minus 2 to the third power is 8. 11 minus 8 is 3. So that would be 29 minus 3. The next thing I would have to do anyway is this exponent here. 6 squared would be 6 times 6, which is 36. So I'm just going to write plus 36 and then divided by 4. So at this point, we've done everything in the group. We've used up all of our exponents. And so now we're just looking at multiplication and division and addition and subtraction. There is no multiplication. There is division. 36 divided by 4. What does that equal? 9. All right. So we got 29 minus 3 plus 9. 29 minus 3 is 26. 26 plus 9 is 35. Exactly. So the answer to the first one, 35. If you want to, I would always recommend, if you're unsure of your answer, if you're working it out using mental math or whatever, feel free to double check it on a calculator. So we can do 29 minus parentheses 11 minus 2. And then the exponent button on these is the little up arrow there. I'm sure you all know that, but this little up arrow there is your exponent button. That would be to the third power. To get this off of the exponent, you have to push the right arrow on the directional path. And then you can close your parentheses. And then you say plus 6 to the power of 2, scroll over once more, and then divide by 4. And there's our answer, 35. So checks out. We're good to go. If you feel like I'm moving too quickly or you have any questions along the way, please ask. Otherwise, we'll just keep on plowing forward because my expectation is that you all know this. So, all right. Number 2, we got 4 to the third power minus the absolute value of negative 8 times 6 divided by 16. Absolute value bars are treated like groups, even if it's only one number inside of it. Absolute value is what? What does absolute value mean? Who remembers that? Yeah, distance from 0. Distance is always positive. So if you think about a number line, right, you got 0 here. Positives, negatives, okay? So positives and negatives, I had to turn around and figure that out in terms of your perspective. So -8 to 0 is how many spaces away? 8. Yeah. So the absolute value of -8 is 8. And then we can also deal with this exponent here as well. 4 to the third power would be what? 64. Yeah. 4 times 4 times 4 is 64. So we're going to have 64 minus the absolute value of 8, which is 8 times 6 divided by 16. Oh, by the way, these do not do absolute value. So if you want to type this whole thing in, you can. You would just need to change that into just straight up 8 if you want to type in the whole thing. To the third power. So you would type in 4. Start off with 4. And then this thing right here is called, I think it's called a caret symbol, but it's like a little up arrow up diagonally from the 7. So you do that and then type in 3. And to get it back down, go to the directional pad and push the right arrow on that. There you go. Yep. All right. So we got 64 minus 8 times 6 divided by 16. We do have multiplication and division. We have to deal with that first. This 8 is a -8. Please keep that in mind, that if you have numbers in a series of expressions and operations, if you have a symbol to the left of it, that represents whether it's positive or negative. That is a -8. So this is -8 times 6, which would be what? What's that? -48. And then we divide that by 16. -3, yes. So -8 times 6 is -48. Divided by 16 is -3. So that would be 64 minus 3, which would be 61. So if you want to do that on your calculator, over here, yep, that definitely looks better over there. So we got 4 to the third power, and then the absolute value of -8 is just 8. So we'd have minus 8, because that is 8 times 6 divided by 16, 61. So let's do 2 more together, and then I'll have you do 5 and 6 on your own. So number 3.
All right, the last group of juniors. As juniors' last name starting with the letters S through Z. S through Z, please report to the library to check out a Chromebook.
That way. Okay. This one has a group within a group within a group. So we got our group, absolute value, within our group, parentheses, within our group, numerator. Group within a group within a group. And then on the denominator, that's another group. So we'll deal with that separately. Basically, you're working from the inside. So we're starting with 10 minus 12. What does that equal? -2, good. And then we take the absolute value of -2, which is 2. So we would add 2 to 5 squared. What's 5 squared? What's 25 plus 2? 27. All right, so we're going to have 7 minus 27 over, let's see, 9 minus 2 squared. 2 squared is 4, so I'm just going to write 9 minus 4. So then we're going to have the numerator, the denominator, and then we'll probably need to divide at the end because the fraction bar is the same as division. We all know that. What's 7 minus 27? -20. All right, so this equals -20. 9 minus 4? 5. -20 divided by 5? -4. Cool. If you want to type this in all on your calculator at the same time, you can, but again, you have to deal with this on your own first. So you would start on this one by actually opening up a fraction. This is the n over d button, the numerator over denominator. So you push that button there, it opens up a fraction. And then you get your numerator going. You got 7 minus parentheses. We said that 10 minus 12 was -2, then the absolute value of -2 is 2, so that's 2. And then plus 5 squared, and then close the parentheses over 9 minus 2 squared. And there it is, -4. Yeah. Absolutely. Yeah. Yeah, if you want to do the numerator as its own set of parentheses and then put a division symbol in between that and this in parentheses, yes, that is the exact same thing. You got it. Cool. All right. Let's do one more together, and then I'll have you do 5 and 6 independently. So unless you want to move ahead anyway, I don't really care if you move ahead if you know what you're doing there. I feel like it's just good review though. So let's see, 2 minus 3 squared plus the square root of 81, that's a group up there, all over 10 minus 6 divided by 3. So start in the like most contained group, which would be that 2 minus 3 squared. 3 squared is 9. 2 minus 9 would be what? -7, okay. So if everything in here equals -7, what's -7 squared? Is it? 49, positive, right? Okay. If you are using your calculator, I'm sure you've heard this 1,000 times by now. If you are using your calculator to square a negative, how should that be written on your calculator if you're squaring a negative? So if I write that, it could, well, but it was -7 in the parentheses, right? Okay. I know the answer is going to be the same, but like, I do want to talk about the calculator convention real quick, because what happens if you type that in? Anybody know? Yeah, it says -49. Did you know that's the right answer to that problem? If you put -7 in parentheses and square it, you get the answer that you know is the one that you want, which is +49. Those are two different problems. Yeah, it's a good question, huh? Because of order of operations, actually. And since this is a lesson on order of operations, let's talk about it. I'm going to write some off to the side. So -7 squared like that is different than -7 in parentheses squared. -7 in parentheses squared means take -7 and square it. -7 times -7 is +49. Who here has heard the word opposite of instead of negative? Instead of saying negative, the opposite of. Anybody heard that before? So like if you have a -x², oftentimes your teacher would say the opposite of x². You're familiar with that? So instead of -x² is the opposite of x². Well, the opposite of 7 squared is what this means. This here is the same as that. Right? When you have a negative next to a variable, it means essentially the same thing as -1 times that variable, right? So if you have something like this, stands to reason that x would be the same thing as 7, the negative would be independent of that. Therefore, we would have -1 times 7 squared. What your calculator is doing is it's squaring the 7 before it's applying the negative, because the negative is like multiplying by -1, and exponents happen before multiplication. Therefore, that equals -49. So if you don't use parentheses, your calculator is going to show you the correct answer to that problem, which actually is -49 because of order of operations. So when you square a negative on your calculator, put it in parentheses. Or just use mental math. It's up to you. Okay. Going back here. So this, everything here is going to be equal to 49. What's the square root of 81? 9, because 9 times 9 is 81. So on the numerator, you'd have 49 here, plus 9 here. What's 49 plus 9? 58. All right, so we get the numerator equal to 58. Our denominator, 10 minus 6 divided by 3, do the division first. That is a -6 divided by 3, which is -6 divided by 3. -2, so 10 minus 2 is 8, okay? That doesn't divide evenly, does it? No? Okay. It does reduce though, doesn't it? As a fraction? Yeah. What does it reduce to? 29/4, yeah. I'm just gonna double check because I'm used to a lot of this Gina Wilson stuff to be integer answers, and so I'm just gonna double check to make sure that I did this right, because I am prone to making mistakes as well. So let's see, 2 minus 3 squared. Close that up. Good. Plus square root.
Only sophomores, please go to the library.
Oh, wait.
So if there's any juniors or seniors left that have still not checked out a Chromebook, please go to the library at this time.
Yeah, that's good. 29 fourths. Go. All right. So 29 fourths, which, by the way, is a perfectly acceptable answer. Improper fractions, I have no problem with. I would prefer an improper fraction most of the time over a decimal, to be honest. Although this decimal would be not bad. Yeah, the fourths end up being pretty nice decimals. 7.25. So you can do 7 1/4 as well if you want to as a mixed number, but improper, perfectly fine with me as long as it's in simplest form. So 58/8, not so much. 29 fourths, yes. All right. Give 5 and 6 a shot. Feel free to group up and check your answers with people near you as well. Let's say 3 minutes. So at 9:30, we'll come back and we'll check those answers to 5 and 6. If you have questions along the way, so deal with everything in this. I think it was. The numerator is also. Yeah. So stuff inside these everybody but it doesn't want to in this case, it would be only that. Sorry, the printing on number 5 is a little wonky. The outside ones here, those are actually brackets. You can't really tell on the top because they don't indent on the top because they match up with this line here, but on the bottom you can see they come in just a little bit. Those are brackets. They're like parentheses. Those are not absolute values. So you got absolute value here, parentheses here, brackets here, not absolute value. So one set of absolute value, one set of parentheses, one set of brackets. All right. So let's just go ahead and run through these real quick. Number 5, we're going to start inside the absolute value. So you do the math first before you take the absolute value. Something that I notice, I teach Algebra 1 a lot. Something I notice is that a lot of people will take the absolute value of all the numbers inside the absolute value bars and then do the math. But you should do the math first and then take the absolute value. For example, don't change that -6 to a 6 and then add 2 with it because you need to take the -6, then add the 2, then take the absolute value. It changes what the value of the number is when you do that. So -6 plus 2 would be -4. The absolute value of -4 is 4. So all this equals 4. Then you're going to add the square root of 9. The square root of 9 is 3. So 4 plus 3 would be 7. So everything here in these parentheses equals 7. Then you can subtract that from 15. 15 minus 7 is 8. So everything on the numerator here is 8. Then you square that and you get 64. So the numerator should turn out to equal 64. From there on the denominator, 3 to the third power is 27. And then 3 minus 27 would be negative 24, right? Things look okay so far? Am I wrong? Okay. Tell me if I'm screwing up. All right, and then 64 over 24, or negative 24 rather. So let's see, those are each divisible by 8, right? So that would be negative 8/3. Is that what we got? That sound good? Hopefully, okay. Negative 8/3. If you didn't get that and you're not sure why, let me know. Happy to go over it in more detail if we need to. Or if you want to, you can type in this entire thing. Your calculator doesn't have brackets, but you can just do double parentheses. That's fine. And then just change, solve the absolute value on your own. That equals 4. So if you want to change that negative absolute value of negative 6 plus 2 to a 4, and then just do a bunch of parentheses and write it as a fraction, it should give you negative 8/3. Questions on that one? All right, let's keep going. Number 6. This one I think is a little bit simpler because there's less like nesting of groups. So let's see, 9 minus 15, what would that be? Negative 6, square it. 36, okay. 7 minus 2 squared. 3, okay. So 2 squared is 4, 7 minus 4 is 3. This is 36. 36 times 3. What's that? 108. Yep. So you got 108. That's 7. 7 plus 5 is 12. And then we're going to subtract 5 because the absolute value of negative 5 is 5. So that would be 108 over 12 minus 5. What's 108 divided by 12? Was it? 9. Okay. So we get 9 minus 5, which would equal 4. All right. So number 6, it's just 4. So far, so good, hopefully. All right. Next set of questions has to do with evaluating expressions. By the way, this is the exact same thing that we just did up top. We just need to plug in the numbers for the variables before we actually do the math. Something that I always tell like freshmen on day 1 when we start evaluating expressions is anytime you substitute into a variable, put the value of that variable inside parentheses. It's just good practice. Even if it's positive, it's not a bad idea. So for example, A, I would replace that with parentheses and a 3. The reason why is because putting more parentheses on a calculator will always get you the right answer. If you accidentally leave off parentheses when you should have them, you will get the wrong answer. And so erring on the side of caution and always using parentheses is not a bad practice to adopt. So let's see, we'll multiply that by negative 4 squared over the value of C, which is 8, and then plus 12 right there. So we're just taking the values of A, B, and C, substituting them in. And now we have problems that look exactly like the ones up top. So let's see, negative 4 squared is 16. 16 times 3 is 48. So that's 48 on the numerator. 8 plus 12 is 20. Those are each divisible by at least 4. So, yeah, 12/5. Yeah. All right, 12/5. There it is. Or what, 2.4? You're going with the decimal? Okay. All right, so that's number 8. Number 7. Try number 8 if you haven't done that one already. And by tomorrow, everybody will have their Chromebooks, so we'll get Google Classroom stuff going tomorrow. Okay. Oh, what? Yeah. Maybe these guys that are gonna bucket up here the same style of scientific activity, so feel free to go grab one. All right, anybody have an answer? Like a final answer? What do we got? 52, sounds good. So let's see, start with the exponent here, that's 9. And then we have multiplication here and here. So 10 times 2 is 20. Negative 8 times 9 is negative 72. 20 minus 72 is negative 52. And the absolute value of negative 52 is 52. So there we go. What's that? Do a little more? Yeah, for sure. So we're good with the 9 here, yeah? Okay, and so then we've got 2 sets of multiplication. So that would be 10 times 2, which is 20. And then this is a negative 8 multiplied by 9, which would be negative 72. So you'd have 20 minus 72. And then negative 52 to positive 3. All right. Cool. Go ahead and flip it over. Keep going. All right. I have no interest in doing all of these. So let's go ahead and we'll definitely do number 9. And we will definitely do number 10. Skip 11, skip 12, and then we'll do 13 and 14 as well. So there's enough similarity between 11 and 12 and the other ones. All right, so 9 is actually a really good one to take a look at because of the negative here, which is just like what I showed you on the front with the using parentheses or not using parentheses on your calculator. This would be the opposite of x squared plus 7 times quantity y plus 2 minus 1. So what we're going to do is that negative is not part of x. That negative is in front of the x. The squared is also not part of x. The squared is an exponent that goes with x, but it's not actually part of what x is. So when you plug in for the value of x, this is why parentheses can be really useful, is we're going to do our negative first, then parentheses, then just the value of x in those parentheses with the 5, and then the exponent goes on each time.
Sophomore, your last name starts with the letters G through L. Once again, sophomore, last name G through L to the library to check the Chromebook.
So the rest of it is right there. And this is something that you can type directly into your calculator if you want to, but I think it correctly matters. So we have the opposite of 5 squared, which would not be 25, it would be negative 45, because this happens after the exponent. And we're going to add 7 to whatever the stuff inside the parentheses here is, negative 9 plus 2 would be negative 7. And then we'll subtract 1 to 30. Yeah. So getting things plugged in correctly is just as important as being able to do the math correctly. So starting with groups though, so we'll go order of operations here. Negative 9 plus 2 would be negative 7. And then moving on to exponents, you'd have 25 with the negative would be negative 25. So you got negative 25 plus, this is negative 7 inside the parentheses, times positive 7 would actually be negative 49. So plus negative 49, and then minus 1. And if you want to, you can just add the 2 negatives together and keep them negative, because a negative plus a negative is like adding 2 positives, but they stay negative. So that would be what, negative 74? Okay, minus 1 would be negative 75. So here we go. There's our answer. All right, now I chose the next one because we have a fraction with one of our variables. Okay, here's your bravery test for your honesty here. Who still has a little bit of like anxiety about fractions? Anybody? Yeah? If you do, that's okay. We are going to deal plenty with fractions in this class. I will try to make them as understandable as I possibly can. But yeah, sometimes fractions are something that people just are like, personally, I prefer fractions so much more than decimals. I find them, once you get good at using them, I find that they're actually easier to work with than decimals. And when it comes down to it, being able to use fractions is going to be absolutely vital, both for the success of this class and pre-calculus and or calculus, if and when you get there in high school or in college. So we got 3r minus 4s. So we're going to have 3 times the value of r. R is 5. That's easy. Minus 4 times the value of s, which is 2/3. Now, this is actually going to be a really quick problem because we've got two things that we have to multiply, two sets of multiplication, and then some subtraction. So 3 times 5, that's 15. Minus. All right. Here's how I deal with fractions. If you have a whole number multiplied by a fraction, just multiply the whole number by the numerator of the fraction. That'd be -8, right? And then if you can, simplify the denominator, but -8/3 doesn't simplify, so you'd have 15 minus 8/3. Now, in order to subtract fractions, this is going back to like probably 4th or 5th grade now. What do you have to have? What's that? Okay, put a 15/1. All right. Now what do we have to have? Common denominator. Yeah. 15, we're going to, split into one group, is a different type of measurement than 8 split into 3 groups. So we need to make the groupings the same. Now, the nice thing is this is a 1, which means we can turn this into 15 in group of 1 to something out of groups of 3, but that's going to increase this by a factor of 3 as well. So if we multiply by 3/3, what do we get? 45/3. Yeah. So 45/3 is the same as 15/1 because 45 divided by 3 is 15. So it means the same thing. So this would be 45/3 minus 8/3. And then all we have to do is subtract the numerators. 45 minus 8, which would be what? 37. Fairly certain that 37 is prime, so that's not going to reduce, so we just get 37/3. By the way, something I love showing my Algebra 1 students is the idea of making a common denominator. Because what we did here is we multiplied the 15/1 by 3/3 to get that 45/3. And the reason why you have to multiply both the numerator and the denominator by the same number, some of you were probably told this before, maybe some of you weren't. But does 45/3 have a different value than 15/1? No. What number was the only number you can multiply by to not actually change the value of the number? 1, right? So if I wanted to multiply 5 by a number to keep the answer 5, I would have to multiply by 1, right? To make that work. That's what we just did. What is 3/3? 3/3 is 1. So we're technically multiplying 15/1 by 1, different form of 1, but any number divided by itself actually is 1. So we're not actually changing the value of this number to get that. We're just multiplying by a unique form of the number 1 in order to get from here to here. So that's why we have to multiply the numerator and denominator. So I know that sometimes that's not always taught like super clearly, but that's why. All right, let's keep going. Let's substitute in. Actually, you know what? Do those two on your own. How about that? Do those two on your own. And we'll just get through this today. We'll do the solving equations tomorrow. Friday was supposed to be a work day anyway, so we can just do the final lesson on Friday and we won't be behind it all, so it'll be good. I'm guessing they probably told you wherever you're picking those Chromebooks up, but your password has been reset for your Chromebooks. Did they tell you that? Yeah, your passwords are your student ID. And then it's going to ask you to make a new password as soon as you get logged in. So just a heads up on that. Anybody have a numerator value for number 13 up? Final answer, but just a numerator value. That on the top. Is it? Negative 64? Yeah, okay, sounds good to me. And then down here will be what? 6, right? Yeah, okay. So negative 64 sixths. 64 is not divisible by 6, but they're both divisible by 2, right? So negative 32 thirds. Does that sound good for number 13? Okay. So negative 32 thirds for number 13. Question, what is 1/4 squared? Was it? (1/16). Yeah, 1/4 squared is 1/16. It's like 4 times 4, but you're just multiplying the denominator by 4 instead, and 1 times 4 is 1. So, by the way, squaring a fraction, multiply that by itself, multiply that by itself. So 1 times 4 is 1, 4 times 4 is 16, 1/16. 2 times 1/16 would be 2/16. Yeah. 2/16 would be the same as 1/8, right? So this whole first part turns into 1/8. And then 9 times 1/4 would be 9/4. So 1/8 plus 9/4. We need a common denominator, which would be 8, right? Yeah. So 1/4 squared would be 1/16. 1 times 1 is 1, 4 times 4 is 16. When you multiply the 2 by 1/16, it just goes with the numerator. So it'd be 2/16, and 2/16 would be 4 over it. And then over here, 9 times 1 is 9. So you have 9 points. And so then common denominator here would be 8. We just need to multiply this one by 2/2. So that would be 18/8. So 1 plus 18 would be 19. So 19/8. And 19 is prime, so that does not reduce. There we go. Cool. So we're out here in about 8 minutes or so. We got just a few questions left down here at the bottom. This will get us set up really well for tomorrow's equation solving review. So for the final 6 questions down here, we're not going to be figuring out any numerical answers at all. We are going to be simplifying by using the distributive property and combining like terms. So reminder here, you can only combine like terms if they have the same variables and the same exponents. If there are exponents, I don't see exponents though. So basically, if they have the same variables on here. And then regular numbers go with regular numbers. Usually what I do, especially with Algebra 1 students, is all like color code things, or I'll use different shapes around certain things to show what goes with what. I will do that today as well in here just to remind you all what's going on with that. So the 16x would go with the negative 7x, and the negative 11 would go with the positive 10. Terms with x go with terms with x, regular numbers go with regular numbers, combine those things just like you would with regular adding or subtracting. So you'd have 16 minus 7 here, which would be 9. And would it be 9x? Would it be 9x squared? Would it be just 9? What would it be? 9x, good. Combining like terms means only deal with the coefficient values. Coefficients are the numbers that are in front of the variables. You've probably heard that word before. So the coefficients, 16 minus 7 would be 9. Combine the coefficients, keep the variables and exponents, if there are exponents, the same when you combine like terms. Negative 11 plus 10 would be negative 1, so 9x minus 1. What do you have to do first on number 16? What is it? Distribute, yeah. So we're going to distribute the 2 to the 3n and to the negative 7. Distributing means
You're a sophomore, your last name starts with letters M through R, N through R. Please go to the library.
Distribute by multiplication. So nothing changes with the 13 yet. 2 times 3 is 6, so plus 6n. 2 times negative 7 is negative 14. Plus, I said negative 14, I wrote negative 17, negative 14, plus 19. And then we'll combine our like terms. By the way, variable terms always go before the regular numbers. Regular numbers in this case are known as constant terms. So variable terms before constant terms. So we've got negative 6 plus, or not negative 6, 6 plus 19, 25, so 25n. 13 minus 14 is negative 1, so 25n minus 1. By the way, if you can use mental math and just get everything figured out without necessarily showing the work, I'm okay with that. 17, we have to distribute twice. We have a 6 to distribute here, and then we have a negative to distribute there. Distributing a negative is the same as distributing a negative 1. Yeah. So 6 times c, 6c. 6 times negative 2 is negative 12. Negative 1 times 8c would be negative 8c. Negative 1 times 1 would be negative 1. 6 minus 8 is negative 2, so that's negative 2c. Negative 12 minus 1 is negative 13, so we get negative 2c minus 13. That's number 17. Number 18. Which variable should go first in our simplified expression? The y, yeah, alphabetically. So, you know, math conventions usually say go in alphabetical order, so we'll start with y. So that'd be negative 15 plus 1, which would be negative 14. So that's negative 14y. And then negative 7 plus 9 would be positive 2. So that would be plus 2z. I usually draw a line through my z's because sometimes I don't make them sharp enough and sometimes they look like 2's. So that's more for you to know that that's a z and not a 2. So you don't have to do the line if you don't want to. All right, a couple more here. Actually, you know what? We're just going to go ahead and stop there. These are really similar to the ones we already did. So let me get your assignment handed out. Because the day is super short today, we don't have a lot of time to start. You got about 5 minutes, though. There's the front and the back of this. The front has order of operations, a little bit of evaluating expressions. The back is evaluating expressions that are evaluating. So go ahead and take one and hand these down. These will be due tomorrow. We will check the answers pretty much first thing. And then we'll move on to our review lesson on solving equations.